Hey folks, how's it going? This is Mr. Moray coming to you with a do now activity for the 3/16/2020 lesson. Okay, so welcome. We are now officially into the COVID-19 shutdown. I hope that this does not last too long because I do have a good amount planned and I want to make sure that we're able to not fall behind it all, ideally during these at least next couple weeks. So I'm trying to put some stuff together on my time to kind of help you guys stay fresh. And so if you have not found it yet, you really want to check out we.willnot.fail, which essentially just will point you back to a page that I've set up on willnot.fail that will help you find what we're doing on a day-to-day basis. I really recommend you find that Google Sheet and then bookmark it, because if you bookmark it, all you have to do is just go there from your bookmarks and you never have to go to the willnot.fail again. You can just bookmark it and go right back to that page. Okay. So here's the do now for this lesson. The do now is solve the triangle. So what I mean by this is I have a triangle here, ABC. Okay, now one thing we need to remember are that the big letters represent the angles, the small letters represent the sides, okay? And so for any given big letter, its small letter will always be right across on the other side of the triangle. So for example, this is little a, this is big A, this is little b, this is little c, okay? So what we're going to do is this. I need you to solve this triangle here, okay? And that means I need you to find all the angles and all of the side lengths. Please keep in mind that this triangle, okay, is not a right triangle. It is not. I know that C looks to be 90, but if you know that the three angles of a triangle, if you know what they add up to, then you know, based on what I know so far, that C is not going to be equal to 90 degrees. It cannot be. Okay, so this is not a right triangle. Sine, cosine, and tangent by themselves will not give you any information, okay? So we need to use one of our laws, okay? So what I want you to do is take a moment, pause the video, okay? And then when you do the answer, okay, unpause, and we'll see if your answer was correct. All right, so I'm going to throw in another second as a pause. I'm going to throw in a little hint here. The hint is that you need to use the law of sines to solve this problem, okay? So if you, in that pause, really did not know where you need to start, I recommend that you try this again with the law of sines, remembering for us, that's handout 3-12, and this stuff, at least for 2019-2020, and this stuff has been around so long that it's easily findable online. Okay, you should have this in your 312. If not, find it online. But if you haven't gotten it yet, please make sure you take a second and pause again now. I'll let it be kind of quiet for a few seconds. Pause it now. Try it again to make sure you got it, and then when you're ready, I'll move on to the answer. All right, so again, for this activity, because it's a law of sines, you're going to need to have access to a graphing calculator. On the right here, you can see that I've got my TI-84 Plus Silver Edition simulator. Okay, I really recommend, and I posted this on the page at we.willnot.fail for our class. I recommend, if you don't have a calculator, okay, you need to have one. You need to have access to maybe an electronic one or something that can do the math. So I recommend you go to Wolfram Alpha, like the Greek letter, .com. Okay, wolframalpha.com. You can type in the math problem you want to do, and it will tell you the answer. Ideally, you need to get a hold of a calculator that can at least do the four main operations: addition, subtraction, multiplication, division. Ideally can do square roots, and needs to be able to do sine, cos, tan, sine inverse, cos inverse, tan inverse. If you have a scientific calculator that you can get a hold on for this part, that would be okay, because we don't need the graphing features right now. So if you can get a scientific, if that's what help you actually be able to engage with the problems, if that's what it needed, I'd be fine with that, okay? So what we have here is we have what's called an angle side angle setup, because we were given an angle, a side in between, and an angle. This is the better of the situations you can run into. Remember, we have got angle, angle, side, angle, side, angle, and side, side, angle. And in this lesson, the main meat of the lesson, we're going to again talk about what happens when you have two sides and only one angle. Okay? But in this case, here's what we'll do. We'll fill in the given information. So here's what I know. I know that A is 23 degrees because that was given. I know that B was 73 degrees because that was given. Okay? And now, if A is 73 and B is 73, sorry, if A is 23 and B is 73, then they add up to 96 degrees. And so what do the three angles of a triangle have to add up to? They have to be 180. So here, there's only one option for angle C. So let's go ahead and try to solve this. So I'll borrow one. I'll make this I'll borrow one here. Make that a 10. Make that a 4. This becomes a 17. So this becomes an 8. So my angle C should be 84 degrees. And again, I just took 180 and I subtracted the sum of A and B. In ASA and AAS, we're only going to have one solution, okay? And what we're going to see is that when I give you SSA, the other scenario, what happens is that, well, actually, there's two possible answers that you could get for your remaining angles, right? Because I'm saying there's two angles that we don't know, and as it turns out, you might not actually get one possible combination of valid angles. You might actually get two or none. So we'll get into that situation a little bit later. When I do give you two angles, right, if you have two angles, then because of what we know about what the angles of a triangle have to add up to, that is 180, we can deduce, in this case it was 84, what the third angle is. Once we know what all three angles are, that is going to in turn limit the possibilities of what the corresponding sides can be. So if A is 23, B is 73, and C is 84, we should only have one possible combination of sides. Now in this case, we were already told that little c was 10, so we just need to find little a and little b. And so to do this, remember I told you two things. First, you always use the exact information. When we do A and B, little b, we are not going to get exact numbers. We are going to get decimals. Do not use those decimals to solve the rest of the triangle. So that is, when I get A, little a, it's going to be a decimal. Don't use little a to solve for little b, because it's not an exact number, it's a rounded number. And so if I plug little a into the formula, if I round it, I'm not really plugging in the right number. I'm plugging in about the right number. And I don't want to do that, because then I'm only going to get about the right answer, not really the right answer. So I'm going to use the exact numbers. Now I know you say, Mr. Murray, aren't you rounding anyway? Yes, but when you round, you throw away a lot of important information, right? And it actually, when you round, you're not really giving exactly what the answer is. You're giving about what the answer is. And so one of the things we want to do in math is we want to attend to precision. We want to be as precise as we can be. So I'm going to use the law of sines, and here's how. I know, and I'm going to choose C because I have big C and little c. So I know that the sine of 84 degrees over the corresponding length of 10 is equal to the sine of 23 degrees over the corresponding length of A. Now notice there's one piece of information that is not known, and that is little a. So to solve, I'm going to cross multiply, and I get a times the sine of 84 degrees is equal to 10 times the sine of 23 degrees. And now to get a alone, I'll divide both sides by the sine of 84. So a is equal to 10 times the sine of 23 degrees out of the sine of 84 degrees, okay? And what's really cool about the law of sines is that because of how we derived it, what we're essentially doing is we're using sine, cosine, and tangent, which ordinarily would only work with a right triangle in a situation where we are not having a right triangle, okay? Because remember, that was the motivation for law of sines. How do we do this stuff when we don't have a right triangle anymore, okay? And law of cosines, which we'll learn eventually, will be similar. So I'm going to do 10 times the sine of 23 out of the sine of 84, okay? And I get 3.92. Just to make sure I'm right, let me just make sure I'm in degree mode, which you can see I am. If you look at the third line here, it says degree and not radian. So that means, and I'm going to round to let's round to 3 decimal places. So A is not equal to, it's about 3.929 units. I'm not going to make you write anything down in this case because there's no units implied. It's not a word problem where there's units implied. It's not a situation where the units are actually in the triangle. So if you left it like this, I personally would be fine. If you want to put unit, you can do that as well. So units. Okay. Now this actually makes sense. We'd expect we'd expect little a to be a lot less than C, because A is 23 degrees and C is 84 degrees, and so we expect the larger side to be across from the longer angle. Similarly, we're going to expect little b to be longer than little a, but not as long as little c, but probably closer to little c than little a, because 73 degrees is closer to 84 degrees than 23. Okay, so that's our hypothesis. B is going to be between A and C, but closer to C. So let's see what happens. So here what I'm going to do is I'm going to do the same thing. Now I'm going to set up sine of B. So I'm going to do sine. Now B was 73 degrees. And it doesn't matter how you set it up. But in this case, I'm going to use, again, sine 84 over 10. So here's what I'm talking about. Notice how I did not use sine of 23 over 3.929. The reason I'm not doing that is because, as you can see on the calculator, A is not really 3.929. It's actually 3.928833848 and then other stuff. That's just what our calculator is showing us. So I'm going to go with 84 and 10 because I know that big C is exactly 84 degrees and little c is exactly 10 units. So you go with what you know exactly. Don't use the things that have been rounded, please. Okay, if I cross multiply, I get b times the sine of 84 equals 10 times the sine of 73. Okay, and I get b alone, and b is equal to 10 sine 73 over sine 84. So it was actually very similar to this one right here. Okay, you can see the difference is that instead of doing the sine of 23, I'm doing the sine of 73. So actually, to save myself time, if you have a calculator, graphing calc, if you hit up, and you actually highlight over something you've already typed in, and then hit enter, it will actually copy that into a new line. So I'm going to save myself time that way. And I'm going to turn this 23 to a 73 and then run it again, and I get 9. So again, you can see it's not an exact number, 9.616. So as I predicted, okay, this triangle, this side of the triangle is much longer than this. It's about 3 times as long, a little bit less than that. And it is not as big as C, which we knew it was going to happen, But notice it's closer to C, significantly so, than it is to A. A is about 4, B is about 9.5, and C is 10. Okay, so we can see those are very close. So this is our final answer. We have A is 23, B is 70, and I'll put C, I'll put this 84 in blue. So the blue is what we found, and the green is what we're given. Okay, so here's my final answer. A is 23 degrees, B is 73 degrees, A is 84 degrees, A is 23 degrees, B is 73 degrees, C is 84 degrees. Then little a is about 3.929 units. Little b is about 9.616 units. And little c is 10 units. Okay, so I hope you found this informational video to be helpful. I put it together just to give you a little bit of a warm-up to make sure you understand what we've done up to law of sines. If this stuff is still confusing for you, I need you to reach out to me over email, over Remind, request a Google Hangout. Hopefully we can do that. But I need you to understand this stuff because we're now going to be moving on to what happens when we have two sides in an angle and there's going to sometimes not be one exact answer. Sometimes there could be two. Okay, so again, please make sure you understand what I did here. Right, keep working at it, and remember, you can do it. All right, folks, thanks for watching. Much appreciated. Head on over and check out my next videos. I recommend you like and subscribe so you can get access to those videos a little bit easier. Please make sure, especially during any kind of school shutdown for us, we're watching out at we.willnot.fail or your class's specific Google Doc page for any updates. Thanks so much for watching. Stay in touch. Have a wonderful day. Don't forget to love math.